So let's start our today's lecture. प्रपोजिशन जो हमने कल नहीं की थी उसका प्रूफ हम आज करेंगे. If we have two partial maps, if theta psi belongs to px, then domain of theta composition psi is equal to image of theta is equal to image of theta intersection domain of psi, then this theta inverse, and its image is given by image of this composition is equal to image of theta intersection domain of psi of theta, okay, of psi theta, and finally for all x in x belongs to domain of the composition, x belongs to domain of theta composition psi is x, image of x under theta composition psi is equal to x theta, then psi. Proof. So let's choose a point x here. Let x belongs to domain of theta composition psi. Let x belongs to domain of theta composition psi. So by definition, then there exists, say, y belongs to x such that x y x y belongs to theta composition psi. It's the definition of domain. Now we apply the definition of composition again. There exists z in x such that there exists z in x such that x z belongs to theta and z y belongs to psi. तो यहाँ तक हमने सिर्फ डेफिनेशन अप्लाई की है. Now this x z, it belongs to theta, so that where is z? Z is in x, z is in a domain of theta, and z is in domain of psi and image of theta, na? Because x z belongs to theta, zy belongs to psi. So it follows that this implies z belongs to, here it's image of theta, image theta, and here it's in the domain of psi. ओके, सो इसको मैं इरेज करूँ इस पेज को. अपना वीडियो आप ऑन रखिए. Okay, that means z belongs to the intersection image of theta and domain of psi, which implies z belongs to the intersection image of theta intersection domain of psi. Also we have this zx belongs to theta inverse because xz, you already have xz belongs to theta, xz is in theta, so zx belongs to theta inverse. So which implies that this x it belongs to, this implies that x is the image of, x is in image of theta, image of z under theta inverse. So x belongs to z theta inverse, x belongs to z theta inverse, x is in the image of z under theta inverse, but z belongs to image of theta intersection domain of psi, so it means that this thing is subset of, it's contained in the image, because z is contained in this image of theta, इसका नाम आप ऊपर 1 रख दीजिए, image of theta intersection domain of psi of theta inverse by 1. So therefore domain of theta composition psi, is contained in image of theta intersection domain of psi then theta inverse. यह आ गया एक साइड से आपका इंक्लूजन, इसका नाम आप 2 रखिए. Now let's choose an element in this image of theta intersection domain of psi of theta inverse. Now let this x belongs to image of theta intersection domain of psi of theta inverse, So therefore by definition there is z such that so thus there exists z, thus there exists z in image of theta intersection domain of psi such that x comma z belongs to theta inverse, or you can say z comma x belongs to theta. You can say this x belongs to z of theta inverse like this, or xz belongs to theta inverse, the pair xz belongs to theta inverse, or this implies xz belongs to theta inverse, and which again implies that zx belongs to theta. Zx belongs to theta. Yes. ओके इस पेज को मैं अब इरेज करूं. So what is this z? Z is an image of theta in domain of psi. Okay, let's read this page. Since our z, it is in domain, it's in domain of psi, so there exists y in x such that z comma y belongs to psi, z y belongs to psi. So zy is in psi, and this x is in theta. X is in theta, so which means that x comma y is in theta composition psi by definition of composition, because this x z जो आपने भी उस पेज पर लिखा x z belongs to theta, so it's the definition of composition. Okay, x y belongs to theta composition psi. So it means that x belongs to the domain of theta composition psi because it has an image y under x has an image y under theta composition psi, which means that x is in the domain of theta composition psi. So thus we have this image of theta intersection domain of psi of theta inverse is contained in domain of theta composition psi. This is third. From second and third, we get this domain of theta composition psi is equal to image of theta intersection domain of psi of theta inverse. इसका सेकंड पार्ट आप खुद करोगे, इमेज का थर्ड में दिखा दूंगा. Now a third part. थर्ड पार्ट में आपको लेना है ये कंपोजिशन में कोई एलिमेंट है. let x y belongs to the composition theta composition psi. Okay, x y belongs to theta composition psi, then there exists z in x such that x z belongs to theta and zy belongs to psi. Since all these relations are partial mappings, since theta composition psi, theta and psi are all partial maps. There are partial maps, so therefore the image is unique. Y is the image of x under theta composition psi. It's unique, so it means that this y is equal to the image of x under theta composition psi, and here the image of x is z under theta, so it means that this z is equal to x theta, and third one, image of z under y is psi, so that means y is equal to z psi. This implies x of theta composition psi, it's equal to y. What's y? Y is z psi, and this z is equal to x theta of psi. So the composition of theta and psi is in case of partial mapping is, it is just the composition of partial maps. जो आप mapping इसमें composition करते हैं, ये वही है जो आपने कंपोजिशन डिफाइन किया ना दिस रिलेशंस में, उनको जब हम मैपिंग्स पर अप्लाई करेंगे, दैट कंपोजिशन इज जस्ट द कंपोजिशन ऑफ मैपिंग्स.